¿Por qué estamos transmitiendo por Zoom?
¿Qué?
Nada, que esto me fastidia.
Ah, no sé lo de Zoom. Bueno,
No importa, no importa.
decisiones.
Creo que lo hemos logrado. ¿Por qué estamos transmitiendo por Zoom? Nada, que esto me fastidia.
Ah, no sé lo de Zoom.
Ay, ojalá que eso no hubiera salido. Bueno, ellos no entienden. Creo que lo hemos logrado. ¿Por qué estamos transmitiendo por Zoom? Perdón. Sorry, we had the audio on, so it was echoing. Let's see, because okay, this is the output.
You sure?
I think so. I hope so. Zoom. All right, guys. So here we are again at the observatory tonight, and what are we gonna observe tonight, Marcel?
Well, before that, Happy New Year's to everyone.
That's a good point.
It's been a while since our last
Transmission.
But yes, we're happy to be back here. Today we hopefully we have, it seems like we have clear skies. I do hope we can start our observations with Mars. You know, it's a very exciting planet. So I think if the sky behaves correctly tonight, if we don't have too much atmospheric interference, we can start there. And from there, I think if we have a chance, it would be interesting to see some of the nebulas that are appearing in our sky shot or sky map tonight. So that would be very interesting to catch a few.
It's kind of cold tonight here in Boulder, isn't it?
Oh yeah.
Yeah. So is Mars out? Is Mars out now?
Yeah. If you look at the map over there, you might be able to see it. Before going to Mars, shall we calibrate the?
Let's make sure they see the map. They see the screen that they have to see.
For all the people that may have joined us right now,
All
if there is
guys.
anyone, please do comment in the chat if you have any questions, if you have any comments, if there's an issue with audio or anything whatsoever, please do communicate it to us. We are trying to be as responsive as possible, answer all your questions.
The camera is already here. What I don't like is I can't control the size of this shot.
I see.
Yeah. But yeah.
That's so just like the zoom.
Let's close this hopefully. Let's minimize.
Yeah.
All right. So this is the sky we can see tonight. It is delineated by this yellow line over here.
Just for people that are seeing that yellow line, they might see a green line as well. The green line is technically the horizon, but here in Boulder, at the university, we have a lot of buildings and the mountains, so our visibility of the sky is even less.
Yeah.
So yeah, Mars is.
Here's Mars.
So yeah. So
do you focus the camera, Marcel?
Yeah, let's do that. Just point out some star. Gemini is supposed to be out, so I think those, if they're visible, could be nice, like Pollux. They're very bright. I'll just, in order to calibrate, we are going to use this diffraction grate. You've seen it a few times if you've tuned in before. We're going to use this to kind of calibrate the telescope.
So you guys are going to see what the diffraction grating does, because we're going to show it here on the screen. So we're using the camera. We're going to show you pictures taken by the camera of the telescope. And here, focus tools are the commands that we use to. Do you place it?
Yeah.
These are the commands that we use to focus the telescope. So we're going to focus it on Mars. And basically what this does is that it just takes very short exposures and renders the pictures here.
You have to move the telescope to Mars.
Yeah.
There. It's looking at.
Yeah, where is it? I thought it was looking there. Oh no.
Oh yeah, you haven't skewed it.
Okay, good.
Yeah, it's looking. I don't know.
I'm out of practice with the telescopes.
It's been a while.
Yeah, it's been a while. Okay, now there you go. It's pretty much focused.
This?
Yeah.
Okay. Done.
So what tells us whether normally the way you focus a telescope, if it has an eyepiece, you focus it to your eye. So you just are looking at the eyepiece and wait for the image to get sharp. Well, we can do that on the camera. So that's why we have these focus tools that take recurrent pictures. But even then, it is not easy to know when it is focused. Maybe it looks blurry for me, but the picture is actually sharp because I need glasses, for example. So the way that you do it in an objective way is that you use the diffraction gradient, the mask that you just saw, you put it at the end of the telescope, so the light goes through it before entering the telescope. And then the diffraction gradient is focused on the CCD plane, on the plane of the camera, when there's the same distance. This line here in the middle is actually in the middle between these other two lines. And these two triangles are the same angles. Exactly.
I did it with my hands. Okay, so I'm going to take
yeah.
the diffraction grid off so we can actually take some pictures.
Yeah. I'm actually going to leave the camera on the screen so you guys see him taking the mask off. Aha. So that's Mars, and one thing that we're already seeing is that it is saturated, right? It is too bright to resolve. And the way we solve this is by decreasing the exposure time. So the image is just abort the focusing tool. We're not using that anymore. I'm gonna take a photo. And 1 second of exposure time was too much. So 5 seconds is 5 seconds times too much. So we have to have the minimum here, just to see how it looks. And if this is too much light, then we're gonna have to add a filter. So let's see.
So by just reducing the exposure time, we're just kind of reducing the amount of time that we're allowing our camera to actually pick up light from the object, in this case Mars.
Yeah, this is still a little bit saturated here. So you see the bottom in this part of the screen tells you the pixel count. And the maximum pixel count is 65, that number that you read there, that's the maximum. That means that if the object is brighter, a pixel count is related to how many photons are being detected by the camera. So brightness. And if it is at its maximum, that means that that part could be brighter, and the contrast between that part and then the part next to it in Mars could mean something, but we're not going to be able to see it because it's all maxed out at the level of maximum brightness. So what do we do now, Marcel?
So, I mean, we can no longer change our exposure time. So instead of just looking at the full like visible light spectrum, in this case that's what we're looking at, we can choose different filters. So because Mars itself doesn't emit just the same amount of energy and all its wavelengths, so like different wavelengths or different energetic photons, or we have different emission profiles for those. By placing a filter, we basically can reduce kind of the amount of light, or just look at a specific wavelength at which Mars is emitting less light. So potentially we get an image that's not saturated by doing that. We're looking at a wavelength in which Mars has less outgoing light.
So here are the filters. And right now we did have a filter, I think. Yeah, we had the red filter.
Okay.
But you know what the problem with the red filter is with Mars? Is that Mars is red.
Yeah.
So the red filter, I mean, it's filtering something, but it's not filtering that much. And we need more filtering. So we can go infrared, green, ultraviolet, hydrogen alpha, which is ultraviolet. I think this is, but no, this is the Balmer series, so it's
Yes,
blue.
it is.
So this is just a transition line of hydrogen. Do you want to explain transmission lines?
No.
Okay, so let's just end that
Very simply. Yes.
atoms like emit light at different wavelengths, different colors. That's
This
it.
is
This is one of hydrogen's emissions.
Yeah, in this particular case is between the second bounded state and the third bounded state of the hydrogen. So
Yeah. Well, no, that's beta. Alpha is no. No, you're right. It's
Yeah.
between
three and
4 and 2 is beta.
Yeah.
Yeah. Sorry.
no worries. I was like trying to remember.
It is silicon. No, it's silicon. Sulfur. What is this?
Sulfur. I think it is sulfur.
This is
S
sulfur.
is sulfur.
Yeah, this is sulfur and this is oxygen lines. What we're gonna do is that we're gonna choose green. Move it. And now we are going to the camera. And now we are going to take a photo. This is also beaming.
Then people are watching. Do you want to say hi in the chat as well?
Hello, guys. Oh, yeah. Mo,
Oh boy.
I don't understand this.
See.
Guys, can you say hello on the chat? We cannot access the chat for some reason, but we don't need to.
Yeah.
I
can log in from my phone.
The binning of a telescope, or with the software actually, when you bin something, basically you decrease the resolution of the camera, right? If the camera has 10 by 10 pixels, and each pixel is its own bucket of photons, that's going to tell you the photons that it received. When you bin it, you by a 3 by 3, you grab 9 pixels, and you make it one value, and you assign one number to 9 pixels. So basically, normally you take the mean, or you just add all of the values for each pixel, and then you make a brighter pixel. Why would you want that? Because it increases, it decreases the resolution, yes, but it increases the signal strength. So what we call signal to noise is better when you bin. But this is the thing, because it was binning, we don't know if it was actually saturated.
Yes.
So we have to go back to the red filter.
101.
Yeah. So do you guys understand why we're going back to the red filter? We were not sure if that picture was saturated, the one we saw. And what we want we don't want to saturate the camera, but we want the highest possible pixel value. That is not the maximum. So that we have the maximum amount of signal. Intensity. Take 4. Let's see. No, it is saturated. Yeah.
But still, we needed to check.
Yeah, yeah. Okay, so let's go to the green filter. Again, guys, it is saturated. This picture is saturated. It's not a good one. And I know it looks, maybe it looks too ugly. You may be thinking, hey, you guys can certainly do better for a picture of Mars. And we can, basically, by changing the contrast of things and fiddling with the image, we're gonna make it better. But before that, we have to get the best picture possible. Okay? And to get the best picture possible, we have to make sure that it's not saturated. And this one is saturated because here we see that it reaches the maximum pixel value of this camera, which is 65,535.
Mm-hmm.
So green. Do you know why we don't see green in the sky? That's something that actually, I guess we have seen pictures with greens, but if you ask a solar physicist, you're a solar physicist, the sun peaks in the green.
Yeah.
Why is it not green?
What do you mean, why is it not?
Why, if the sun peaks in the green?
Yes.
And not in the yellow?
Yes. I mean, why don't we see the sun?
What isn't it green? Yeah.
Isn't it like atmospheric absorptions? Like,
we don't see it green when we go to the, in the pictures.
In space, you mean?
Yeah.
I don't know.
I've always thought, hey, maybe it's just like the black body spectrum is too broad, certainly.
Mm-hmm.
So you're getting red and you're getting red basically, and that's where it's going to yellow.
Oh, I see. So it's just like the combination of colors.
That's what I'm thinking.
Even if it peaks on green, because you have so much more like red and.
Yeah, but I'm not satisfied with that explanation.
I saw something similar like that in the video.
Okay, take picture.
I don't think people can actually comment on the chat because I commented 2 things that they haven't popped up there.
Aha, so people cannot.
I don't know.
Maybe are they? Sorry guys, it seems like the chat is not working. I think I'm gonna regret this. But let's try to sign in. Guys, we're trying to make the chat work. That is not working. It's also the chat here in Zoom is not working. To make sure.
Next.
Nobody. It's not marble.
Yeah, that's just change the account. Like, yeah, you hit next and you can change the account.
Is that right?
Oh, SBO. Sure.
Oh man.
Oh, you got rid of it.
I got rid of it, YouTube. Yeah, we are live indeed. Sign in.
I don't think that's.
It's not gonna work. Yeah.
Yeah, you. You're still gonna see it. Share your screen.
What do you want? They're seeing that screen over there. Sorry, guys.
Yeah, but
Okay.
no, we can't see.
You want to go to YouTube and to the channel.
Yeah.
Okay.
Exactly. See
We-
something.
Yeah, we're not sure why the chat is not working. But until we figure it out, we're just gonna keep.
Yep. Just leave comments, I guess, on the by the end of this video if you have any questions. We hope to still like show you enough, I guess.
Yeah. This is strange, but I'm.
We can figure out later.
Yeah.
So we wanted to show you Mars, and we changed the filter to the green one.
Mhm.
And I think we've already taken the picture. Or
No, I haven't. Or did I? No, I haven't.
no. Okay. So we are now going to take the picture using the
Taken.
green filter.
Oh no, I had. It is saturated. Okay.
Very bright Mars.
So green doesn't work. Then we have infrared, ultraviolet.
Ultraviolet.
I think blue. I think like ultraviolet is too
Okay.
extreme. I don't know how narrow this filter is. We don't have it over there. Well, let's see.
The edge alpha one's not there.
Yeah. Let's see. We can explore by taking another photo.
And I'm pretty sure this is like a bandpass filter, right?
Certainly not saturated.
Yeah.
Maybe so now we are like in the 20,000s. You can see it down here. So we can increase the exposure. We can increase the exposure time by 2 or 3. Let's try 3.
Yeah, and then afterwards you can actually like work on the contrast and the histograms and show.
Sorry. Yeah, it's gonna take a while to. Not 0.3. We have to do like 1. Let's see what happens with 1 second.
Okay. Oh, you mean like 0.1? Because yeah, 0.0.
0.1.
Oh.
23. Yeah, it's just not. It's not linear.
Yeah.
It's a log. So okay. So if it's a log, we have to do 1 minute. Okay. One second, I'm sorry. 26. Oh, now it's saturated. Too much.
0.5-ish.
A little bit saturated. Hey, we have somebody that's gonna join us tonight.
So
We have a special guest.
we're pleased to
Mhm.
to present soon enough Rachel. And people can interact with us because the shot's not working, but we're happy. We're happy to be there here with them. There's still 10 people watching live with us, and hopefully we'll be able to show you a good picture of Mars soon.
I want to try. Let me try one more thing to make the shot work. Who is Mao?
I think you either through Fabio's or because like to the Zoom you have to like log in through Fabio.
It doesn't want me in because it's on the Zoom.
Yeah, but it's like, can't you like log in through Fabio's account as well here?
What do you mean?
Like you logged in through Fabio's
Yeah,
account
that's what I'm trying.
to the Zoom. So
That's what I'm trying to do. But you see what it does.
yeah, I know, but it's like it's weird. It's heading with the marble account.
No, even if now it's pushing the map. Okay. Even if I do Fabio, now I don't know. Doesn't want to Fabio.
That's
Oh,
forget about it then.
yeah. Sorry guys, no chat tonight.
Go back to the.
To YouTube. All right. So the picture of Mars. I think this is it. Yes. The dream of Mars. Yeah, I mean it is saturated here, but there's a lot of you see all of this contrast we would have lost if we had left it saturated. It is there's some pixels that are saturated, but I can see the pixels next to look at all of these pixels over here that are all saturated. Okay, so one more picture. This is almost perfect. Let's see how it looks. Yeah. Yeah, okay. Let's now well, this is definitely not saturated.
What?
30,000.
Did
What?
like which one was what exposure time were you using before?
I went from 0.2 to 0.3. I mean, there's also clouds and stuff, right?
Yeah, but I think this is.
Let's try 0.3 one more time. I prefer the other one over this one.
Yeah.
Okay, let's see. Yeah, this one is better. Yeah, okay, this is perfect. So remember, there was a point in our lives. Maybe today is the day. No, there was a point in our life that we took a picture of Phobos.
Yes.
You were here, right?
Yes,
I was
yes,
with you.
you're here. So Phobos is just one of Mars' moons.
Maybe? No.
I don't know.
I don't see it. So this bar on the bottom, what it does is what is happening when I'm moving these bars is that I'm setting all pixels to the right of this bar that have certain level of whiteness are all set to maximum white, and all pixels here are set to maximum dark. Right, so here I'm setting more and more pictures dark and only leaving the most brightest pixels, right? And then the gradient between the brightest, this gradient is showing what contrast the software is showing for the pixels in question.
For example, in this one, you can actually probably get some.
That's the brightest spot. Yeah.
I mean, there we can kind of see. I think
I refuse to. Are there clouds?
There's some slight like cirrostratus puzzles. Those are fine clouds.
Which one is Mars?
I think it's all the way over here. So you look at,
Ah,
I
yeah.
don't know if you people in the stream can see our telescope, but it's kind of pointing westwards.
I don't think they can.
No, I don't think they can.
I-
It's not bright enough.
Well, not only that, the shot.
Yeah,
No.
I wouldn't touch that. Not a great.
I will not break it.
Yeah.
All right, so this is a picture of Mars. And given the current conditions, I think it's an okay picture.
Yeah, I mean, we've gotten some here with a little bit more structure, but even though, like, I feel it's a good picture from our last live stream that we couldn't take any, so it's quite an improvement. But yeah, this has been Mars. Do you want to move on to another object, or do you want to keep going a little bit
we
more?
can talk a little bit about Mars and
Yeah.
the picture in question. So, um, one thing about Mars is that it is a planet, and you can obviously see it in the picture. Stars are so far away that if it weren't because of diffraction in the atmosphere, they will cover just one pixel. There will be a point source, not an extended source. That, of course, when you see it through your eyes into the telescope, they look like an extended source because of effects, because of optics, basically.
Yeah.
But here, Mars, because it's a planet, it's actually an extended object, and you can see it in this picture by the contrast, the fact that the brightest thing is not in the middle of the planet, for example. But over here.
Yeah.
So that's a way to say, hey, this is not a picture of a star. This is a planet. Now, what else can you tell me about Mars?
I mean, we can slightly talk about like the planet itself. I do think I have a Windows open.
Oh, I want to show this picture. Okay, you go.
No, I mean, if I'm gonna speak about Mars, it's not gonna be about this picture. I can speak a little bit about the atmosphere of Mars and the luck of it. As a solar scientist, I am very interested in the effects of the sun. Basically, Mars has very thin atmosphere, escaping atmosphere because of the interaction of basically particles of the sun, what we call the solar wind. Because Mars has no magnetic field, its atmosphere is basically a very small magnetic field, is exposed to the solar wind, and this is just like any wind, it blows away because it's so fast, it blows away the atmosphere of Mars. So yeah, this is something that's very interesting to me about Mars as a planet, and especially in contrast with Earth, kind of similar planets and their kind of the actual tilt and the fact that we're not that far away from each other in contrast to some other planets in the solar system. And yet again, like, we have very different conditions in terms of the geology and climatology of both.
Yeah, but also Venus.
Oh yeah, yeah.
So
Venus is another case.
This is the interesting thing is, for me, is that yes, the solar wind blew the atmosphere away because Mars has no intrinsic magnetic field, because it has no metallic core in the way that the Earth does. So the way the Earth creates its magnetic field, we think like this. This is one of the things in space physics and magnetospheres that they don't want to talk too much about it, but how the dynamo is created. So the idea of a dynamo is a moving charge object creates a magnetic field, basically. And if you move around, if you move in circles, you're gonna create a dipole magnetic field, kind of like what we see on the Earth. And the dipole magnetic fields are what you see in normal magnets.
So a bar magnet, for example, like, it's a kind of.
This is not what I was expecting.
Just right, yeah, like, right, like, and that's
magnets field.
Bar, yeah, fields. Bar magnet. Yeah.
There you go. Okay, so So this is, oh, look, huh?
Perfect. Earth.
Nothing like hyperphysics. So the Earth has a magnetic field similar to that of a magnet of a coil. In this loop of wire is just a coil with one turn, right? And we know that this is the shape of the magnetic field of the Earth because we have measured. And I mean, it's also very simply like using a compass.
Yeah.
Right.
I mean, that's how they discovered it.
Yeah, yeah.
1700s.
So this is the magnetic field of a dynamo. Now, in the case of Venus, Venus has no rotation. We think that is because it got hit at some point in its formation, and it stopped the rotation. If you have a planet forming in isolation, it wouldn't stop rotating. But Venus has no rotation. Well, Venus.
Yeah.
Okay. So this is Venus. What about Venus rotation? Well. Yeah. So Venus has no rotation. So it also doesn't have a magnetic field, but it has a very thick atmosphere. I think this is a good picture.
Yeah.
Venus has a very thick atmosphere, so thick that the pressure
very dense
at the surface is how many Earth atmospheres?
I don't know the exact number, but I do know it's like it has like metallic like.
This is not what I want. How much in bars? How much is one atmosphere? It's 93 bars.
I feel like that's less than. Oh no, it's million.
1 bar basically.
Yeah.
So 93 times. That's a lot actually.
Yeah.
So 93 times the weight of the atmosphere of the Earth. That's how much gas is above you if you're in the surface of Venus. That's why we haven't been there for too long. We went there for a little bit before the spacecraft that got sent, which is completely stop functioning. You will understand why.
Yes, it's crushed.
So what is the pressure at the bottom of the sea?
Well, it's not even.
I'm sorry, I don't know imperial units in bars.
Yeah.
In bars.
PSI.
Well, it's 1,000 times. Okay. So it's still like the pressure at the bottom of the ocean, according to Wikipedia, is 10 times more, only 10 times more than the pressure at the surface of Venus. So there's a lot of atmosphere, but there's no magnetic field. How can you explain that? The sun is hitting Venus in the face with all its might. The atmosphere is unprotected, and yet it persists.
I want to say gravity. I don't know why. It's like
that's one of the factors. For sure, Venus is bigger. Venus is bigger. So in Mars, kicking out oxygen specifically is very easy. What happens is an electron comes. There's an O2 molecule. The electron comes. It dissociates the molecule into two oxygen ions, and those things are already ready to leave.
Yeah.
So we already have what is called the escape velocity. The escape velocity of Mars is like 5 meters per second.
Right.
While 5 meters or kilometers. 5 meters per second is like everything
that would
escape.
be very
Kilometers, yeah.
Yeah, very low.
Yeah, the escape velocity of Mars is more or less like 5, and the one of Venus is 10, so it's twice.
Wow.
And this process is photo dissociation of oxygen, which is very effective in Mars. In fact, I think that some of the oxygen, when the oxygen gets dissociated, it can both escape, but it can also react with the surface.
Okay. So yeah, because I mean, Mars itself is a very oxidative.
Yeah. So that explains the color of Mars in part. But that process doesn't happen the same way in Venus. So that's one. The how big it is one reason. And maybe also because it's big, it can produce more atmosphere.
Yeah.
So even if the solar wind just affects the outer layer of the atmosphere in Venus. And what happens is that if you're the solar wind, you're an electric field, right?
Yeah.
Basically, in a magnetic field, you're a field.
Yeah.
And it ionizes the particles at the layer, at the outer layer in the upper atmosphere of Venus. And these ionized particles now have a charge. And because they have a charge, they will react to the fields, and they react to the field in such a way that they nullify the field. So the fields, the inner atmosphere doesn't feel the solar wind at all. Wow, I mean that's Mars. That one is Mars.
Yeah. Oh, I don't want to access
Cambridge.
Yeah.
I mean, this is what we're talking about. But I think this is probably out of the scope of.
You can see the picture there.
You can see the picture. I want one with Venus actually. Let's see what happens.
Oh, it's the same thing. Oh, actually.
I mean, that's
Yeah, but that's something.
So, as you can see that, oh wow, this is very dramatic. This is not how it is.
Yeah,
I mean, actually, this is showing that there's a lot of components here.
Yeah.
There are a lot of components here, but it's not. There's not much of plus actually. It doesn't get there. I mean, there is an O scope. There is an O plus escape rate, of course, but it's not as high as you will think. So what happens with Venus is that the atmosphere itself creates a protective barrier for the solar wind, and all the heavier elements that rest closer to the surface are protected by the upper atmosphere. So this is what is called an induced magnetosphere. And the induced magnetosphere means that most of the solar wind actually doesn't interact with the atmosphere. Most of the atmosphere is safe from the solar wind. This is a good one.
Yeah, I mean, it's in another language, but
Yeah.
I think German.
So yeah, everything here is safe. Everything is here is safe.
And you did mention something about like the production of more atmosphere. You mean like geological like activity?
I think like that's. I mean, the thing is that Mars also had it.
Yeah.
The atmosphere of Mars was produced because of the same type of geological activity, right?
Yeah.
So.
I mean, if the rate is different, then like it could produce like the escape of the atmosphere.
I think that the volume of the atmosphere is very important. Like this is, again goes back to the size of the planet, because the atmosphere only interacts with a surface, with a layer of the atmosphere, and the volume of what's behind that is what's going to replenish it, right? And the volume is is proportional to the cube of the radius, and it will be proportional to the cube of the radius of the atmosphere and then the planet. So it goes very, very high with size. It increases quickly with size. So I think it goes back to being big.
Yep.
To Venus being bigger. Yeah, I would like to have a more interesting insight in it, but
I mean, it's a very interesting topic, and I mean, like to our viewers, I hope that you might be interested in this as much as we are.
I mean, there's another component that may play a role into why Venus has a and it has to do with the composition, not the rate of production,
But the actual composition.
For
of
the actual
atmosphere.
composition
Yeah,
of the
yeah.
atmosphere.
Yeah, because I mean, if it's as you were mentioning, if it's not like depending on the molecules or like atoms that you have in your atmosphere, like
Yeah.
the actual processes or interactions with the solar wind.
The ionosphere, which is a layer of charged particles that all planets with atmospheres have, including the Earth.
Yeah.
The ionosphere
Where you have radio.
in Venus is very effective at negating the effect of the magnetic and the electric field.
I see.
So it acts as a superconductor. It's not a superconductor. I'm not saying that it's a superconductor, but it acts as a superconductor. So magnetic field superconductor. Let's see. Hopefully not nothing crazy. Aha. So here, this is a very good example. This is a magnetic field without the ionosphere.
Yeah.
It just goes through and interacts, goes through the planet, and then it interacts with the entire atmosphere, and it can shed all of it away instead of just the surface. But if you have this situation here, where the magnetic fields have to go around, that happens. That's what happens. It's very similar. What's happening? The superconductors are conductors with no resistance. So when the magnetic field interacts with the superconductor, it's going to create a current. And the current is going to create a magnetic field. And this magnetic field is going to be such that it's going to negate the total magnetic field inside of the superconductor.
Wow.
And then there's going to be no magnetic field. I don't know if you guys have heard of Faraday cages. Well, the magnetic superconductors are like Faraday cages, but for magnetic fields. The Faraday cages is for electric fields. And Venus ionosphere is so dense, and it has such a charge density.
Yeah, because it does. That I remember that the composition is very populated by like sulfur ions and like different types of like ions, methane and other type of stuff like that.
So maybe there is something that is not just that the planet, but well, not that the planet is big, that the atmosphere is big.
Yeah.
And voluminous, you know. Okay, so that's Mars.
That's Mars. That's Venus. That's Earth, and the solar wind. Quite a journey.
Now, I would like to hear questions, but you guys can't access the chat. I'm sorry.
The Alexa doesn't work.
For some reason, like it's not working. Like
Let me
I
try
tried.
something.
You can try. Like I tried to like write a message to see if it popped up, and
It did pop up.
it told me like you don't have permission to do that.
Oh, and let me do it, but it said error.
Yeah, exactly.
Yeah, the
Yeah, I mean,
Yeah.
I would like to try before we leave, even like to see if it's possible to catch the Crab Nebula, and that's Mavo's account, which keeps popping up.
yeah. I think I'm sure that it has to do because we're already logged in. on Zoom.
Yeah.
So Zoom doesn't do comments. You have to separately log in into YouTube to read the comments, and it's not letting us.
Can I log in on my computer, maybe?
Maybe that's gonna be weird, but
Just like YouTube from her computer.
yeah, but you have to see what the Gmail.
Yeah,
Fabio's-
that's but can you just actually check on the this time?
So
it says-
so log into CU Observatory. Go. I'll help Rachel. Go and go to a nebula or something.
Yeah. Careful. Okay, so we're mentioning we're trying to solve this issue with the Zoom chat, and in the meanwhile, we still have like some 10 minutes to spend here, and we talked a lot about Mars and kind of like the solar system here. But I was checking earlier, and there might be a chance to see a planetary nebula called the Crab Nebula. Actually, I'm not sure if it's a planetary nebula. Take that back. And let's actually see if we manage to catch it, and if not, we'll try to catch a star cluster, which are also very interesting because stars, of course. So what I'm gonna do here is you can see our sky map again, and what I'm gonna do is I'm going to go to find, and I'm actually just gonna type Crab Nebula. See, so our second option here is the Crab Nebula. So I'm gonna go find. So actually see, okay, so it pointed to where it was, and I'm gonna hit slew. So if you can see here where my mouse is, we're actually pointing at Mars. So we're gonna actually move eastwards to see if we can actually catch the Crab Nebula, and the sky looks
I
pretty
have an
clear.
just give me an idea. For well, she's trying to.
Okay. Well, if you need the computer, like it's already moving to the Crab Nebula. So because the Crab Nebula is such a distant object, not like Mars, we are gonna try to like again change our exposure time, probably increase it a little bit more to see if we can actually catch a good number of photons or just enough light from that object. So I'm gonna go to our camera options, and as I mentioned, the exposure right now is 0.3 seconds. We are gonna go a little bit higher than that. To start with, let's start with 1 second or even more. So let's go to 5 seconds. And we're probably gonna change our filter as well, filter wheel. And we're gonna change, actually H alpha might be a good option. Let's leave it at H alpha for now. And we're gonna go to camera, and now we're just gonna take the picture.
Do you see my comment?
I don't know. Let's see.
Go to YouTube. Go to the video.
That's not it.
Oh, he said just said something.
Ah. Yay.
Oh, hello, sir. Finally, we've managed to get comments going.
Yeah.
Thank you, Rachel. Thank you, Danielle, for this. And in the meantime, we actually might have. Oh, I don't know if this is the picture that I took. If it is, it's probably. I don't know if I actually even hit take a picture. We're gonna take that picture again, just in case.
How much exposure? 5 seconds?
Yeah, put it in 5 seconds. Probably has to be higher, but. Well, yeah, it probably has to be way higher.
The filter. What filter do you have?
Using H alpha. Maybe change it, yeah.
Sadly, there's no transparent filter, but red.
Red maybe, yeah.
Yeah.
No. God. We go crazy.
Do you answer him?
Yeah.
Did you manage to log in there? I think that was it. Probably
Somebody
just
had to log in. Yeah.
probably just logging into the.
Which my idea was to use Firefox.
Oh, that was it.
No, here in this computer, if we had tried to log in through Firefox,
Okay.
maybe we could have logged in.
Maybe, yeah.
Yeah. So somebody needs to be logged in a browser, not in Zoom.
The picture we took looks like probably looks like nothing. Yep, just a bunch of nothing.
Well, how much we have 5 minutes. Let's do 5 minutes. Or do you already do 5 minutes?
Go for it. 5 minutes. Let's.
That's 10 minutes.
600?
Isn't that
Five?
10 minutes?
5. Wait.
Yeah, 6.
Yeah.
300.
Jesus Christ.
3,300.
My hands are too cold, so I can't think.
Yeah. I'm too cold, so I can think.
Viewers feel. Please do. We're sorry that we couldn't actually get your questions before, but we're happy to answer any
Yeah.
if there are. Right now we're trying to see the Crab Nebula. We're hitting the maximum exposure time here, 5 minutes, and seeing if we can catch anything. If not, we will move to a star cluster because stars.
I mean,
right.
Okay. Hopefully we can because.
We don't have too much time.
Yeah, exactly. We're close to 9 p.m. over here.
Yeah.
And I want to go home.
No, I do as well. Like I just pointed like this guy over here is a star cluster. So. Questions. Oh, Danielle actually.
Well, if you
Did I arrive on time?
if you go there, you can tell.
Oh,
Yes.
No,
Yes.
You
yes.
can tell if you build a rocket. Okay.
Actually.
maybe we don't have the budget for a rocket. What's our alternative?
A cheaper option.
Let us say that you can space travel.
So you guys saw the picture of Mars, and you guys saw how I was telling you that it was obviously an extended object instead of a point source. Because it is an extended object, then the diffraction of the atmosphere is going to affect less the amount of light that you see from it. So its image in your eye is going to be more stable than a star. So basically, the stars twinkle more. It's not that planets don't twinkle, but stars twinkle more than planets. And it's because stars are a point source, so it's very easy to move the source of light out and in of your eye, while if you have an extended source, move the entire thing out and in, it takes more turbulence in the atmosphere, so it's less likely to occur. Do we have our picture?
It's still going in progress.
Oh.
Gonna take forever.
Let's see what the observatory has for us.
Now it's actually like saturated. Got it.
I mean, I think it could also be Twinkle Little Planet.
Well, Twinkle Twinkle Planet, not three twinkle.
Yeah, Twinkle, like big planet.
Like gaseous
Put it
planet.
away.
Yeah, I imagine like it's harder if it's not a like rocky planet. I imagine like gas giants and stuff like that are more harder to detect because of the I guess
Honestly,
it's yeah, it's more.
let me tell you, honestly, the first thing I do to know if it's a planet is to see if it's in the ecliptic. You know what I mean?
Yeah.
Like, if it's around where the sun goes, so the ecliptic is this line over here. That's where planets are. That's the plane of the solar system. And if you see something right around there, it's probably a planet. If you see something bright, like right where it shouldn't be, like I don't know, over there, that's not a planet, because it's not. Planets are not there, right? Like Sirius over there. That's not a planet, because that's not what planets are. Well, it's actually, well, planets are a little bit lower. Yeah. Or Orion.
Well, in the meantime, you can just show them a picture of the Crab Nebula. In case we don't actually get to see it.
Do we? Oh no. Yeah, we have 30 seconds for the best picture of the Crab Nebula ever.
Yes, it's actually going to be better than NASA's picture. It's like,
It's gonna be better than James Webb's picture.
yeah, so
Are you gonna compare it with that?
yeah, this is
the cheap version of what we're gonna get right now.
yeah, exactly. Like the fact that they have to like actually like color this image just shows the quality of
Yeah,
of this. Ours is gonna be like way better.
it's gonna be more real, more crude, more raw.
True to the science.
Like yeah, like it has aesthetic to it. You know, the black and white pixelated. Okay,
Progress.
are you ready? Are you guys
Just
ready?
progress. Yeah, okay. Let's see this. I'm ready to see a just dark sky.
Why are the pixels from the telescope like? Yeah, you were right. Whoa, go
Whoa! Whoa! What's up? Say that picture.
I gotta say.
I was like, no.
So this, my friends,
My friend.
my friends.
It looks like something I sneezed out this morning.
Whoa, that's gross.
You sneeze on the
This
telescope?
is a star sneeze. It's what they do. Once they just grow too old, they just sneeze all over the place.
So what do we know about the Crab Nebula? So we have a guest astrophysicist here
Oh god.
Ooh.
that knows all about stars.
Ooh.
No, I don't.
Well, now you
You're
do.
the one who knows about
Oh,
stars.
now you do. This guy was asking me about Mars, so.
So what do we know about Crab's Nebula?
Is it a planetary? I know how like it's a supernova, the remnants of a.
What?
Isn't it?
There is a star, right? There's a pulsar.
It's a white dwarf, right?
White dwarf? I mean,
I thought it was a
that's
pulsar.
it's a pulsar. Look it up.
Like we can listen
We
to
gotta
it.
look up Peter P.
Oh, might be.
So
Yeah.
but anyway, you're right. You're all right. It's a planetary nebula, which means that it comes from. It comes from a planet. That's what it means. No, not really.
No. I was like, what are you talking about?
It comes from a star, so it comes from a supernova. Supernova is a big explosion, and this is the smoking gun of it.
Yeah, the planetary aspect of it is just a historical artifact because it's circular, it's spherical-ish.
Is that why?
Yeah, I think that's what I read, like, or what they taught me. It's like just because like they seem like round objects, so they seems like a planet.
I mean, I guess that this could seem round in physics world, like assume this is spherical.
I mean, imagine looking at that like with a very low quality telescope. Like I can.
Let me see other contrast.
Yeah, I was gonna say like I'm
Yeah.
very sure we can get better. See?
Ooh.
Yeah. Ooh, that looks great. That's the one for the Instagram.
This is the one from the Instagram.
Yeah.
Okay. I'm gonna.
Oh look, it's our last session observations, the little droplets. That's what we were observing last time.
Yeah. Let me save us.
So
Set it.
it's already 9:00. So for all those that are still with us, we have to say thank you so much for staying with
Yeah.
us. We managed to see Mars, talk about the atmosphere and a lot of other stuff about Mars and Venus. And we managed to capture this picture of the planetary nebula.
Today I learned that maybe I should. Maven, you know Maven.
Yeah, the like mission,
Yeah.
Mars mission, right?
Yeah. Anyway, Maven is a mission that is in among many things, it is exploring the magnetic field environment of Mars, and it is trying to understand this idea of atmosphere escape.
Mm,
Yeah. I just learned something about the mission today, but
nice.
I don't think I should say it public, like to everyone.
Yeah.
Yeah.
Well, thank you very much for tuning in. We have the next open house, Danielle. Do you know when it is?
It is the last Friday of the next month.
So just look at the calendar 1 second. That is,
And we're going to have, again, Erin and Gilly. So now you have a Mars specialist. Erin has been studying Mars for a long time, and she will be very happy to answer all your math questions that we didn't answer today.
so that will be
The
February 26th.
26, yeah.
Write it down.
And Gilly is another solar physicist.
Yes.
Because it turns out there's a lot of them among us.
Yes, yes. Probably Gilly knows a lot more. He's been here a little bit more.
Yeah. All right, guys. See you in a month. How did I spell